from Idaho. I strive to provide interesting videos about motorcycles, fabrication, welding, electronics, machining, and general creativity. I hope you enjoy. Hello from Idaho. Well, I got myself a new cup. This one's made out of stainless steel. I said I wouldn't do it, but it's actually working out pretty good. I got a couple of pictures of the Scout on it, and it's got a top, and it works on my heater, so life is good. So as you might be able to tell, today's about lighting. I bought these lights off of Amazon, and they're going to be daylight running lights for the Jeep. Let me turn all this off. I was just doing a little test here to show you how bright they are and to look at the current draw. I'm running at 1.02 amps. Even if I kick the charger up to the start position, I still get about the same. Okay, that's probably easier to see now. Some people don't care for daytime running lights. I do. Probably because I'm a motorcyclist, and there's a reason there's a national headlight requirement. It's my understanding that daytime running lights are required in Europe. They tend to have quite a few more safety requirements than the U.S. Their motorcycle driver's license is significantly harder to get than the U.S. one, something that some Congress critters are going to try to change. But nonetheless, Europe, I believe, has a daytime running light requirement. And in the U.S., there are no states that have a daytime running light requirement. However, due to my own research, I believe they actually help. I had a Chevy HHR for a back and forth to work car, and it had daytime running lights. General Motors is pretty consistent with that. And there was a little switch, and so I would do 1 month with daytime running lights off, 1 month with daytime running lights on, and I just alternated that way for 9 months or so. And I would keep track on a little notepad how many times someone pulled out in front of me, not pulled out in front of me, but pulled out in front of me where I had to brake, or someone turned in front of me where I had to brake. And my own data showed like a 9 or 10% difference. And I was commuting about 250 miles a week over this 9 months, same course back and forth to work, and then after work going to buy groceries and whatnot. And I could show a 9.5 or something like percent difference in my notes, and using those criteria. Not that someone pulled out in front of me, but somebody pulled out in front of me where I had to brake, or someone turned left in front of me where I had to brake, or other instances where people weren't seeing. And so with the factory daytime running lights on, which are not really very bright, I got less of those than I did with them off. On my motorcycle, I've done a similar experiment with a modulated headlight. Now, all motorcycles are required to have a headlight on, but the modulated headlight flashes. There's a federal regulation that tells how fast it has to flash, and that it can't be on at night. There's a bunch of conditions, but anyway, you can buy modulated headlight modules. And so I did kind of the same experiment on my Scout with a modulated headlight, and it's quite a bit different. I got like in front of me where I had to brake, or someone, turning in front of me where I had to brake or whatever. Motorcycles just aren't seen that well, and a modulated headlight helps with that. So, at any rate, the long story to say, I'm putting daytime running lights on the Jeep. I bought these off of Amazon a whole year ago. They're Nightlight. I'll put the Amazon page picture right here. And they come with a whole bunch of wiring. There's a fuse and a switch and a whole bunch of connectors and whatnot. But I don't like connectors. I'm not going to have a switch. I'm going to wire this in so that anytime the ignition or the accessory circuit is on, the light will be on. And I'll show you that on the Jeep. But I went to the wrecking yard and snipped out an entire fuse box for the Jeep. And I was going to scavenge some of the posts, some of the wiring connectors out of it, and put it into my fuse box so that I would have more fuses, more locations where I could put fuses in, and so I could power more stuff. That was kind of old world thinking. In the era I grew up with, if you wanted to run driving lights or something, you had to figure out a way to get power, run a pretty hefty wire up into the dash to a toggle switch, another wire back out to the bumper and a ground. And so everything went through the firewall twice, and you had a high current switch on the dash. But that's not how you do it today. There's a lot of remote switch panels that are available from like $160 all the way up to $600 or $700. And they give you a little cube that's got X number of switches. There's 6 and 8 and 12. And so what you run through the firewall is a little what looks like a telephone wire, runs up to this little panel, and the fuses and the relays and everything are actually under the hood. That's what I'm going to do if I need to add any more lights. Ideally, I would have liked to put the running lights on there, but they do not provide a provision for a normally closed circuit. Everything is normally open. And I didn't want to add another relay to switch the sense of that. So I'm just going to run them all the time, anytime the ignition's on or the accessories are on. Since I've only got to run one wire, I'm going to use something that is kind of clever, but a little bit of a kludge. Basically, it's a wire that plugs into your fuse box and has places for 2 fuses, a bottom and a top. And so you take it and plug it into your fuse box in place of an existing fuse. Let's say windshield wipers. So you plug it into the windshield wiper circuit, and you take the fuse that you remove from the box and you put it in the bottom. And now that circuit works as normal, but it also sends power through the second fuse and out this wire. And so if you're going to wire a bunch of circuits up, you got a whole bunch of them in there, and it's a little bit of a pain in the butt. But since I'm only going to ever have to do one, I'm just going to use this to wire up the power for my little daylight driving lights, or daylight, what do they call them, running lights, daylight running lights. So I guess we should move outside. Okay, it's been a while, but I'm back on my daylight driving lights. I've got my two little night lights, and I have pre-wired the Y and got it all sealed up in heat shrink tubing so it'll be waterproof. I've cut it over length. So these night lights have 2 bolts. Basically, you have a single bolt here and a T-nut in this slot. So by loosening this, you can change the angle of the light with respect to the mounting stud, and you can move it left to right. So I've got one moved all the way towards the right. This will be the left light because I want them to be a little wider than the mounting holes. And I've got the other one turned the other way. And then I've rounded up a couple of non-locking nuts. These things come with lock nuts, which are great for the final install, but as you know, they'll be installed half a dozen times or more during the installation process, the wiring and whatnot. And so I'm going to put these on the Jeep now, temporarily. And here's my cabling installation tool. It's basically a 3/8 inch dowel that's ground down to somewhat of a point with a rounded end. This will allow me to poke a spot in the grommet, open it up a little bit, put my wire through it. Here's the lights from the front, and then the Y, both wires come into the Y, and then they'll follow this pack of wires here down through this big grommet, and then they will follow the cabling that goes to the winch from the battery. So the wires will actually come out around here, which is where the negative and the positive for the winch. And then here's the battery box that we'll be hooking to with our little fuse adapter. So I'm going to take the battery out so to make the getting the wire up through this direction a lot easier. Okay, I've got the battery out, got my battery cables tied back with some bungee cords. I've cleaned out most of the gunk out of this battery tray. And it's time to route some wires. Note that here's the positive terminal to the winch, here's the negative cable to the winch. I've got a vacuum hose. They all run through a small hole in the firewall or the radiator core support. So all I need to do is to run the cable from the lights through this grommet, and there's actually a hole through here already. It's a good sized grommet. ARB does a really good job with wiring. They provide really nice grommets. They provide additional turn signals. It's a very well thought of bumper in Australia. It's actually made in Australia, and they have a different kind of idea of what bumpers are supposed to be in Australia. They're almost always animal catchers, And this one would be really good for catching a deer, a deer if it needs to. Hope not, but if it needs to. Okay, I just need to run the wire down along the winch cables and up through that hole in the core support. I'm not going to show you that. It's going to be boring. It applies only to this kind of bumper, which is pretty rare in the States. And I'll get back to you when it's time to make some connections. Okay, I was making such good progress with the camera off that I forgot to turn it back on. So here's my wire run up underneath the Jeep alongside the power cable. I've stripped back and shortened the black side, which is ground, and it will go to this body ground connector here, which hooks directly to the negative battery cable. That's a good place. It takes a 10mm wrench, and a little word to the wise to you internet mechanics. When a bolt takes a 10mm wrench, it is not a 10mm bolt. It is a 6mm bolt. And so calling bolts by their head size makes no sense at all. Bolt sizes are called by the diameter of the threads, not the size of the head. And that puppy dog is on there tight. Now I'm wondering if the nut is spinning on the back. Yes, it is. Okay, that makes it more complicated. So let me move on with what I was going to tell you. Anyway, I've got this ready to go onto the negative terminal. I'm going to solder on a lug and hook it right there. This wire will hook to power in the fuse box. And I've talked to you a little bit about this already. So here's the fuse box. Okay, the holes in the bumper are quite a bit bigger than the studs that come out of my lights. So I need a reducer. We'll make something like this. Here's basically a 3D view of it. The hole for the studs is about 0.290. That's what the stud is. So the hole will be a little bit bigger. This here is 0.500, and then I'm using 3/4 inch stock, 0.750. This height here will be like 40 thousandths, 40 or 50 thousandths. I don't want it to be thicker than the tab on the bumper, but I want it to be about the same thickness. This thickness here doesn't really matter much, but we'll probably make it like 0.125. So that's 1/8 of an inch. And this distance here, like I said, will be 0. I can't really see it there. I gotta put it over somewhere else. All right, we'll make it here. This will be 0.050 inches. So that's what my little part's gonna look like. We'll cut it out on the lathe, make 2 of them, paint it up with a few coats of Rust-Oleum, and then we'll have some spacers for our lights. Okay, a little dip in some muriatic acid. Get rid of that cadmium plating. Okay, here's my cleaned off bolt. Okay, we're going to cut the shoulder. I'm going to make it 50 thousandths of an inch high. And half an inch. So this part, this bolt is 3/4. So that means I need to go in 250 thousandths on the diameter. If this weren't a washer, I'd be a lot more careful about dimension, but we'll be within a few thousandths. Okay, we're about 1/1000th under. That seems like a pretty good deal to me. Okay, there's my little washer. Got a little hang on right there, but we're basically done. Okay, I did have the weld nut on the fender of my Jeep that was the body ground break loose and just spin. So I took a cut-off wheel and cut it out of there. But I can't really get in there to weld without taking out the inner fender well and whatnot. So what I did was to drill a hole in the fender and build this stud with a handle on it, a flag stud, if you will. The fender will go between these two heavy-duty star washers, and then this will be tightened down on that, And so at that point, I'll have a ground stud sticking out of the fender. And then I'll use a flange nut to tighten down on these two connectors. This big one goes to the battery terminal. This smaller one goes to the lights. I'll take the insulation off of this and I'll solder both of those in there. And so then I'll be back to ground zero of having a body ground and then also having a ground for my new lights. Sometimes you're only a broken bolt away from quite an ordeal. Okay, we're back. So I've got the old connector off of the Jeep body ground. When I got the weld nut out of there, I ended up destroying the connector that was on here. So I've got another one. And then I've got the ground here stripped back as well. And I've got heat shrink on my wire here. It's a ground, so it doesn't really need insulation, but it does help with strain release a little bit. And so I put these on, and then I crimp them with a good crimping tool. This big one really needs a crimping tool with longer handles, but we got a good crimp. That is generally considered good by many industries. However, I'm kind of a belt and suspenders guy, so we're also going to solder it. If you don't have a propane powered soldering iron for your Jeep, I would recommend that you get one. They are very handy. Without the soldering tip on it, it basically has a little flame that comes out here. So you turn the gas on. This regulates the flame height, and then you strike it. So you can hear it's running, and it's hot. But I'm going to solder, so I'm going to put a soldering tip. Now, this is actually my second one of these. My first one that I've been using for a while, I keep in the Jeep. This one's my shop unit, and I just keep the wrench and the soldering iron tips in this cap, so I always have it together. So now we'll start it up again. Okay, now we can see some redness, and this will get very hot, and it'll be good for soldering. I probably could have used just the flame and done just as well, but get a little puddle of solder here to transfer some heat. In general, you don't want to put solder right on the soldering tip, but to get a joint started, to transfer heat, it's a good idea to just put some solder right on the tip. And then once the connector and the wire are hot enough, they will melt solder themselves. And this, like I said, this is a big wire. Copper conducts heat like crazy, and so it's conducting heat way up the wire here right now, so we're going to have to put quite a bit of heat into it before it gets hot. But this is something you can do in a parking lot, on the trail. You can use it to heat shrink tubing. Yeah, see, now the connector itself is hot enough to melt solder. So we'll just keep melting solder into that connector and have it permeate the strands of the wire. And that is a forever connection. And then you just turn it back off again. It comes with a little stand. You can sit it on something. Like if I were to sit it here, that keeps the tip from melting something else. So while we're waiting for that to cool off, so I can do the heat shrink. Right here is my new ground stud. It's got a flag handle on it. You can see in that opening. And there's a star washer on the back and a star washer on this side. I've scraped the paint off of both sides of this hole. I have a special tool for that. And then I put a regular nut on it with some medium strength Loctite, and so that stud will be in this fender and strong and grounded for a long time. Then we'll put this connector on it, and I've got another connector for this wire, which we can also solder. So here's the lug that you saw earlier. I've taken off the yellow insulator. Both of these are made for a 5/16 bolt, which is what I have in the fender. And so I know some people don't understand crimping, but if you look at the connector, the lug, it has a split right across the top. And so you want the round part of your crimpers to go on the split. And then the pointed part of the crimper goes up the bottom. And I don't know how tight is tight enough, but I always do it as tight as I can. Okay, let's get this guy held up here somehow or another so we can solder it. There we go. And we'll fire up our little soldering iron again. We only need medium heat this time. Get a little bit of solder. Once again, I do a little bit of solder on the soldering iron tip. Melt the solder on the soldering iron tip. Just to get some solder on the connector to transfer some heat. Once that solder is transferring heat, then we let it warm up. Then we put solder on the joint on the connector. And it will, when it's hot enough, it'll melt and run into the joint. Okay, there we go. That's forever. For solder with a core, I always squish the end a little bit to keep the core from running out. It can be liquid. Okay, onward. Got the top off of the power distribution center. Most of the fuses and whatnot in here are always hot. It hooks directly to the battery right under here. But the ASD circuit I was talking about before. So here is battery. There's a fuse 19 that let's see which one is 19. Fuse 19 right here. So there's a fuse 19 right here, this 25 ampere that leads down to the ASD, automatic shutdown relay. This thing is normally open when the Jeep is not running, but when the computer wants the Jeep to run, it closes. That sends power down to two more fuses, fuse 21 and fuse 24. 21 is a 20 ampere, 24 is a 15 ampere, and they go down and power the control modules, the ignition coil, oxygen sensors, etc. A whole bunch of stuff. Basically all the power that the engine needs to run. And so what this is telling us is fuse 21 gives us power, has power available at fuse 21 whenever the engine is running. And so fuse 21 is right here, this top sort of center. And so that's this one right here. So if we take fuse 21 out and put it into the bottom of this fuse tap and put this right in like this, now the Jeep is wired exactly the way it was before a few minutes ago, but we also have power available out at this connector. So I've extended my wire, put a little grommet on it, made a little hole in the fuse box for my grommet to go through, and then I will solder these two together. Obviously I don't like butt connectors, but anyway, this fuse tap is pretty handy in that the fuse for the auxiliary circuit, this wire here, goes in the top. The normal fuse goes in the bottom, and then you can plug it into the fuse that you took out. It's tall enough to go over the top of another fuse that's adjacent to it, and it just provides power on this wire. And so when I get these two wires spliced back together, get my battery in there, then we're ready to test our lights. We are done. That wire tucks down in there nicely. My grommet goes in my little slot, which allows the cover to clip on. Okay, that's it. Nothing left to do but to test it. Okay, got my daytime driving lights on. I'm at 300 feet from the Jeep, which is, by Idaho law, the distance where you're supposed to apply a turn signal. It's 300 feet or 5 seconds. Now the Jeep's sitting a little bit in the shade right now. It's 8 p.m. at night or something like that. Anyway, I'm going to show the same thing with the lights off. No daytime driving lights, 300 feet in the shade, 8 p.m. Okay, just a little wrap up. My bench is a mess again. I got my birthday present here, which is a Swag off-road finger press brake. Still need to weld that together. I've got 3 oil changes to do, and filters and air cleaners and all that stuff. Plus the Jeep is going to get a full new set of ignition. So the rule in the shop is if you have a flat surface, it's going to collect stuff. And so right now it's collected all my oil change stuff, my camera stuff, brake lights for the Scout stuff, and my Swag off-road. But at any rate, in closing in the video, these diagrams here are invaluable if you're going to mess with the electronics of a vehicle, and they're available online typically. I found a full set of wiring diagrams for my Cherokee, downloadable free on the internet, and this just happens to be the 2 pages that pertain to my particular issue. I'm actually going to print this one, the one that shows the fuse location and what the fuses are for, half size, and laminate it and put it under the cover of my power distribution box. I keep calling it the fuse box, which is not incorrect, but that's actually the power distribution box. There's another fuse box inside that has most of the fuses in it for the things that actually work in the Jeep, you know, radio and air conditioning and all of that junk. But anyway, this one shows a good picture of where all the fuses are, what the relays do, and it actually enumerates it. Some of this information is already under the cap of the power distribution under the lid, but it doesn't. It just tells you the size of the fuses, not what they do. And so I'm gonna, like I say, I'm gonna print this half size, laminate it, and put it underneath the lid of the power distribution box. This one here shows the relation, the actual wiring of the circuit, and I just printed it out for this project, but I won't keep it around. I've got an electronic copy on my computer. So that's basically how to add daylight driving lights to a Jeep. The way I do it. Lots of other people do it different ways. Depending on how your Jeep was outfitted, you might already have a relay for fog lights and daytime running lights built into your Jeep. My Jeep has the wiring that runs down to the front bumper, but it doesn't have the power distribution center. That has no connectors underneath it, so you can put a relay in there, but it doesn't hook to anything, which is why I had to do what I had to do with mine. This particular model Jeep has nearly no accessories. It's got no power windows, no power doors, no cruise control. It's got the bare minimum of dome lights, and you have to crank the windows up and down yourself, etc., which is fine with me. Those kind of vehicles will last forever. You don't have nearly as many problems with a plain Jane vehicle as you do with one that's outloaded with all kinds of things. And so that's fine for me. I can crank down my own window. So in summary, let me say, hope this helps somebody, and goodbye from Idaho. As usual, if
If you like or dislike my video, please select the appropriate button and let me know why. I really appreciate comments and I will answer every one. If you're new to my videos, please select the subscribe and the notification bell to get more videos like this.